So dear students, today now we are introducing limits, the chapter limits in calculus. Now first and foremost I am going to discuss about the concept of limit. I am going to explain the concept of limit taking an example into consideration. Now, concept of limit. See, let us take a function f of x as x square minus 4 by x minus 2. Where x is not equal to 2. Because as it is a real function, okay? So, if you take x is equal to 2, that f of 2 would be 0 by 0, which is known as indeterminate form. So we have to ignore 2, that function to be a real function. So, however, when x is not equal to 2, this function can be further simplified as x square minus 4 is 2 square by x minus 2, which is equal x plus 2 into x minus 2 by x minus 2. As x is not equal to 2 plus x minus 2 is not equal to 0. So this x minus 2 gets cancelled, then you get x plus 2. So our f of x is equal x plus 2 when x is not equal to 2. Now what I am going to do is, I am going to take a table, okay? See, this table gives you the clear understanding about the concept of limit. Now I am taking table where this table gives the values, various values of x approaching to 2 and the various values of f of x. So at 2 we get indeterminate form, already we have seen. At 2 we get indeterminate form, which is 0 by 0. So this is, we don't consider this, just I am showing you. At 2 you get indeterminate form. Now what is most important for us is left side of 2 and right side of 2. So what does it mean when x approaches to 2 from its left side? This x is approaching to 2 from its left side. And here x is approaching to 2 from right side. So you have to take values of x which are nearer to 2 from left side. So now let us take 2.0, 1. From left side, no, so you have to take somewhat less than 2. Here you can take 2.01. Here you can take 2.01 because this crossed 2. So now here x is approaching to 2 from left side. So you go for 1.9, which is less than 2. So take 1.9, 1.99, okay, like this. 1.999 So, you are making x closer to 2 from left side. Now, you take various values of x which are closer to 2 from right side. Okay? 2.01, okay, 2.1, etc., etc. Now, see, when x is 1.9, what is our f of x? Just now we have seen f of x, we have seen as x, our f of x, f of x we have seen as x plus 2, right? So, we have seen f of x is x plus 2. Actually, originally it is x square minus 4 by x minus 2. But after simplifying, when x is not equal to 2, f of x is x plus 2. So, both please have an idea. This original function with the domain r minus 2. So, if you further simplify this function, it takes the form f of x is equal to x plus 2. Now, when x is 1.9, what would be f of x? 2 plus 1.9, which is 3.9. And it is 3.99. And for this, it is 3.999. At 2, 0 by 0, indeterminate form. So, you should not consider this. So, when f of x is 2.01, 4.01. And it is 4.1, etc. So, here one point is very clear that when x is approaching to 2 from left side, f of x is closely coming to 4. When x is approaching to 2 from right side, even you can see that our f of x is closely coming to 4. So, how you will express this idea? Okay, using symbols. See here, f of x limit x is approaching to 2 from left side. That means you have to take as 2 minus. Okay, when x is approaching to 2 from left side, you are seeing f of x is approaching, going closer to 4. So, it is 4, right? Now, you can also see there, when x is approaching to 2 from right side, which is called 2 plus. So, when x is approaching to 2 from right side, you are seeing our f of x is coming closer to 4. F of x values here increasing and going closer to 4. When x tends to 2 minus, when you take x value approaches to 2 from left side, f of x value increasingly goes and approaches to 4. Are you following? And if you take x approaching to 2 from right side, then f of x value decreasing, for here 4.1, here 4.01, like that. It is decreasing and it is coming closer to 4. This side it is increasing and coming closer to 4. There it is decreasing and coming closer to 4. So, this is called, it is left hand limit of this function and it is called right hand limit of the function, and you see that these both are equal. Left hand limit, right, this is called left hand limit, this is called right hand limit. So, now here you can see both limits are equal, and this is only the stage where you can say that the limit exists. Therefore, the limit of the function exists as x tends to 2, and that limit would be 4. So this is the most important point. So the limit of the function as x tends to 2 is equal to 4. So now you can say limit existing theorem. So limit existing theorem, a theorem which states the rule for the limit of a function to exist. Limit existence. See here, theorem. F of x limit x tends to a exists and it is equal to L, a finite real number, where L is a finite real number. So f of x limit x tends to a is equal to L, where L belongs to R, and L being finite. If and only if this happens, only if the function left hand limit and the function right hand limit both exist and each equal to L. So this is most important theorem throughout the chapter of limits, because every student should know when the limit of a function exists and when the limit does not exist. So that is an important point. So the limit of a function exists if and only if both left hand limit and right hand limit exist and are equal to L. Understood? So this is limit existence theorem. Now so on limit existence, let us do one problem, right? One problem I am doing. Does mod x by x limit x tends to 0 exist? So here we have to state whether the limit of the function mod x by x exists or not. So for that solution, first you have to go for left hand limit. Mod x by x limit x tends to 0 minus left hand limit I am finding. So which is equal to, now you have to change the variable from x to h. How you see, when x tends to 0 minus, x has to be replaced with 0 minus h everywhere. As limit h tends to 0 here, where h is greater than 0. So this is a procedure. You have to calculate the left hand right hand limits. When you are calculating left hand limit, x has to be replaced. X tends to a minus, you will have no. So that x has to be replaced with a minus h. And here you have to put limit h tends to 0, h greater than 0. This is the procedure you have to follow inevitably. So this is equal to, this is mod minus h by minus h, which is mod minus h is h only, by minus h remains minus h. Okay, limit h tends to 0, h greater than 0. H tends to 0, h greater than 0. Now as h is not equal to 0, both h and h get cancelled. So you get minus 1, limit h tends to 0, h greater than 0. This constant has got nothing to do with the limit. So this is minus 1. So you got this limit as minus 1, left hand limit you got minus 1. Now let us see for right hand limit. So if you see right hand limit, mod x by x, limit x tends to 0 plus. So which is equal to, here you have to replace x with 0 plus h by 0 plus h. Limit h tends to 0, h greater than 0, which is equal to mod h by h. Limit h tends to 0, h greater than 0. So as h is greater than 0, mod h is equal to h only. Mod h by h, limit h tends to 0, h greater than 0. So this now h and h get cancelled, you get 1. H tends to 0, h greater than 0. Constant has got nothing to do with the limit, so you get it is equal to 1. So what we have seen here, LHL is different from RHL. So LHL is not equal to RHL. LHL means left hand limit. RHL means right hand limit. LHL and RHL, you are seeing that they are different, because in the previous case you got -1, in the present case you got 1. So they are different. Therefore, what you can conclude, that limit of the function mod x by x as x tends to 0 does not exist. Understood? Now let us do one more problem. Does 2x minus 3 limit x tends to 2 exist? This is a question. So now we have to check. Left hand limit you have to find out, right hand limit you have to find out. You should see whether they are equal or not. Accordingly you have to conclude. So now I am finding LHL, 2x minus 3, limit x tends to 2 minus, which is LHL, left hand limit. As just I said, when you are calculating a minus left hand limit as x tends to a from left side. So you have to replace here x with 2 minus h. So 2 into 2 minus h minus 3, bracket close, as limit h tends to 0, h is greater than 0. You have changed the variable from x to h. This is the procedure to calculate left hand limit and right hand limit. So this is equal to 2 to the 4 minus 2h minus 3, limit h tends to 0, h is greater than 0. So which is 4 minus 3, 1 minus 2h, limit h tends to 0, h is greater than 0. So which is equal to 1 minus 2 into 0, which is equal to 1 minus 0, which is 1. So LHL you got as 1. Now let us see RHL. F of x, limit x tends to 2 plus now, RHL means, which is equal to f of x means 2x minus 3, limit x tends to 2 plus, which is equal to 2 into 2 plus h minus 3, limit h tends to 0, h greater than 0. So 2 to the 4 plus 2h minus 3, limit h tends to 0, h is greater than 0. 4 minus 3 is 1, 1 plus 2h, limit h tends to 0, h greater than 0. which is equal to 1 plus 0, which is equal to 1. So now we have seen that LHL, RHL both are equal and each equal to 1. Therefore, left hand limit, right hand limit are equal. Therefore, you can conclude that limit of 2x minus 3 as x tends to 2 exists. Understood? So dear students, in this present discussion, I am going to clearly discuss about the difference between value of function. Value of function means, say, f of x is equal to x plus 1. I am taking a simple example and I am telling what is value of function. Suppose you are taking f of x is equal to x plus 1. What is the value of function when x is equal to 1? Which is f of 1, which is called 1 plus 1, which is 2. That is called value of the function. So, I am now interested in discussing the difference between value of function and the limit of the function at that point. Whether they are same or different. So, what is the difference? Okay, now you see one point. Here one important point is, listen carefully here. See, sometimes at a particular point, the function may not have defined. So, in that first example, which we took, f of x is equal to x square minus 4 by x minus 2. In that function case, that function has no meaning when x is equal to 2, because you are getting 0 by 0. So the function is not defined at x is equal to, but you see in that example, at the same point too, in the previous example, the table which I have taken and I have shown the concept of limit, right? I am talking about that example. In the same example, you could find the limit f of x as x tends to 2, and you have shown it as 4. So, here what is the information you are clearly getting? See, if a function is though not defined at a point, the limit of the function may exist at that point. So, this is most important point that every student should understand. The first difference is, though f of a is not defined, limit f of x, x tends to a, may be existing. Simply, in a simple way, I express the meaning of the entire explanation which I did previously. So, at a particular point, if a function is not defined, it doesn't mean that at the same point the limit never exists. So, there is no such condition. Though function is not defined at a point, you may get limit. So, there is no interrelation between that function is not defined and limit not being existed. Both are different concepts. Okay, though function is not defined, you may get the limit. That previous table example, if you take, here that function is not defined at 2, but you could successfully find the limit of the function as the same point x tends to 2. We have seen it as 4. Understood? So, this is most important point. Now, secondly, suppose sometimes f of a may be existing. Though f of a exists, it is not necessary that limit of the function as x tends to a should be equal to f of a. Not necessary, I am saying. The second important point is, sometimes you may see f of a defined. Though f of a is defined, it is not necessary that there is no any compulsion that the value of the function at a and the limit of the function at a should be same. Not necessary that they are equal. Not necessary. Maybe equal sometimes, but it is not any condition. It is not a compulsory condition. So function may have value at a, which is f of a. It is a real number, perfectly existing, but that functional value not necessary to be equal to limit value. Understood? So for that first point, I have already taken example. That is table example only explains this first condition. Now the second condition, I will take an example and I will show to you. Now dear students, see this example, which is suitable to explain the second note which I have given in the previous discussion. So f of x is equal to x square minus 9 by x minus 3 when x is not equal to 3, and that f of x is defined as 3 when x is 3. So now here let us see what happens. See here, let us take f of x, limit x tends to 3, let us find out. X tends to 3 means x is approaching to 3 from left or right. Obviously then x is not equal to 3. So when x is not equal to 3, f of x is to be taken as x square minus 9 by x minus 3. Limit x tends to 3. So this is equal to x square minus 3 square by x minus 3. Limit x tends to 3. So which is equal to x plus 3 into x minus 3 by x minus 3. Limit x tends to 3. So this x minus 3 get cancelled, x plus 3, limit x tends to 3, which is equal to 3 plus 3, which is 6. So here you got limit as 6, limit f of x as x tends to 3 you got as 6. Now how the function is defined when x is equal to 3 by definition of the given function, by definition of the function f, when x is equal to 3, f of x is equal to 3. That means f of 3 is equal to 3. So the value of the function f at 3 is 3 and the limit of the function at the 3 is 6. So here now you see, so the function has certain value at 3 which is 3 and the function has certain limit at 3 which is 6. So here you see what you observe, that functional value and the limit value are not same. So this is all finished. So please do understand, these are two important concepts in the limits that you have to understand. Now coming to next point of discussion is algebra of limits. So we take the following properties as granted without any proofs. Now you see what is our heading now is algebra of limits. See, for example, let f of x as x tends to a limit is L, and say g of x limit as x tends to a equal to m, say for a moment. Then we take the following properties as granted without any proof. You frequently apply in the running problems of various exercises. Okay. So now then, number 1, f of x plus or minus g of x as limit extends to a is equal to L plus or minus m. So it gives us the meaning that limit of sum is equal to sum of the limits. Limit of sum is equal to sum of the limits. Second property is f of x into g of x as limit extends to a is equal to L into m. Number 3, f of x by g of x as limit extends to a equal to L by m, where m is not equal to 0 in this case. The fourth, some constant k1, okay, f of x plus or minus another constant k2 into g of x as limit extends to a, which is equal to k1l plus or minus k2m. Understood? Now fifth one, mod f of x limit extends to a is equal to mod L. Sixth one, log modulus f of x as limit extends to a is equal to log of modulus L. Seventh, f of x whole power g of x as limit extends to a equal to L power m. Right? So these are basic things in algebra of limits. Coming to next theorem, which is popularly known as sandwich theorem. So sandwich theorem tell us, I'll write the statement. See, if f of x is less than or equal to g of x is less than or equal to h of x, and f of x limit extends to a equal to L, h of x limit extends to a is also equal to L, then g of x limit extends to a will be equal to L. This is most important theorem. This is popularly known as sandwich theorem. Please do remember this. If the three functions f, g, h are following this relation, and the limit of this function is L and limit of h of x is L, so then that limit of g of x will also be equal to L. So now coming to next point is indeterminate form. See, indeterminate forms. See, we have 6 indeterminate forms in mathematics. I'll 6 or 7 I'll list here, you please check. 0 power 0. This is one indeterminate form. Second indeterminate form, 0 by 0, or you can start with 0 by 0. 0 by 0. Number 2, 0 power 0. Number 3, 0 into infinity. Number 4, infinity minus infinity. Number 5, infinity by infinity. Number 6, 1 power infinity. Number 7, infinity into infinity. So these all are the indeterminate forms in mathematics. This infinity into infinity is not indeterminate form. Instead of, you can take infinity power 0 is indeterminate form. So infinity power 0 comes under in the list of the indeterminate forms. Okay. So see, for example, here you see, suppose say f of x limit x tends to a is 0. Suppose say g of x limit x tends to a is 0. Then f of x by g of x as limit x tends to a. Okay. So this is, if you use this property, f of x limit x tends to a by g of x limit x tends to a, which equal to 0 by 0 indeterminate form you get. But in fact, you should not get any indeterminate form in evaluating the limits. So in evaluating limits, you should not get indeterminate forms. Any of these 7 indeterminate forms you should not get. So evaluating the limits of the form 0 by 0 belongs to one set of problems. Next, evaluating the limits which take the indeterminate form 0 by 0 to the power 0, that goes to another set of problems. So like that, okay, we have to do 7 sets of problems now. Coming to first set. So evaluating the limits of the indeterminate form zero by 0. Understood? Now I will take one example. You see, evaluate x square minus 3x plus 2 by x square minus 6x plus 5 limit x tends to 1. So we have to evaluate this solution. So now x square minus 3x plus 2 limit x tends to 1 would be is equal to 1 minus 3 plus 2 which is equal to 3 minus 3 which is equal to 0. And if we evaluate x square minus 6x plus 5 as limit x tends to 1, which would be equal to 1 minus 6 plus 5 which is equal to 6 minus 6 is equal to 0. So the limit is now x square minus 3x plus 2 by x square minus 6x plus 5 as limit x tends to 1 would be equal to 0 by 0, which is indeterminate form. But the limit should not be in indeterminate form. So now we are evaluating the limit of a function which takes the indeterminate form 0 by 0. Okay, so how to evaluate? You see here, I'll explain. As you got indeterminate form, so you should not stick to that value, because indeterminate form cannot be the answer of a limit, answer for the limit problem. So how we have to change the program and how we have to evaluate the limit, you see here. Now take x square minus 3x plus 2 by x square minus 6x plus 5 as limit x tends to 1. Now you go for factorization x by splitting the middle term, x square minus 2x minus x plus 2 by x square minus x minus 5x plus 5 as limit x tends to 1. Equal taking x common, x into x minus 2 minus 1 common, x minus 2 by x common, x minus 1 minus 5 common, x minus 1 as limit x tends to 1. So on the whole you go for x minus 2 common, x minus 2 into x minus 1 by x minus 5 into x minus 1 as limit x tends to 1. So here you see, as x is approaching to 1, x is not equal to 1, so x minus 1 is not equal to 0. So x minus 1 get cancelled. Then you are left with x minus 2 by x minus 5 as limit x tends to 1, which is equal to 1 minus 2 by 1 minus 5, which is minus 1 by minus 4, which is 1 by 4. So like this you can evaluate the limits of the functions which take the indeterminate form 0 by 0. So this is one of the methods, factorizing. So now let us go for another problem. Evaluate limit x tends to 0 root over 1 plus x minus 1 by x. So you easily observe this is also see 1 plus 0 root 1 is 1, 1 minus 1 0 by 0 indeterminate form. So this problem also under the same heading we are solving. So now let us go for direct finding the limit, avoiding the indeterminate form. So now you see you have to go for rationalization here. So if you rationalizing the numerator, so 1 plus x minus 1 into root 1 plus x plus 1 by x into root 1 plus x plus 1, rationalizing numerator, limit x tends to 0. So a minus b into a plus b, a square minus b square, so 1 plus x minus 1 by x into root 1 plus x plus 1. Now this minus 1 plus 1 get cancelled, x by root 1 plus x plus 1, limit x tends to 0. So limit x tends to 0. So are you following? So now this will be equal to 0 by root 1 plus 1, that is 2. 0 by 2 is 0. So the limit of this function is 0. Understood? Right.